Nothing better than a nice Saturday to talk about binary trees, right? So today, what we're going to do is we're going to go through a problem walkthrough together. It's a little bit more involved, but I think it's good for us to go through one more problem together so that we can practice umpire and just practice binary trees. Then after that, you guys are going to go into breakout sessions. Hopefully your mentor will be here with you guys today to help you on our exercise. So our breakout session today will be a little bit different than the usual. We'll talk about that once we get there. But after our breakout sessions, we are going to talk about a non-technical topic that I think is also very important for us to talk about is other types of interviews. So right now we're practicing whiteboarding, algorithmic data structure types of interviews. But obviously, when you go to interview for an internship or full-time positions, there are other types of interviews that you need to prepare for. So we're going to talk about that today, and we're going to talk about the tips that I have for preparing for those types of interviews. And again, if you have any questions, please ask it in the Slack help channel. I will not be monitoring Zoom chat during the lecture. I remember I looked through the Zoom logs after my last lecture, and it sounds like people are still asking questions there. So please, if you see your fellow classmate asking questions there, I will not be looking there because I can't monitor two chat logs at the same time while lecturing. So please, at least in Slack, I can answer your questions via comment when you're in breakout sessions, so I can get back to it. So I'm not really able to do that in Zoom. Zoom is just really hectic in terms of chat. So please ask it in Slack. So we're going to go ahead and dive right into a binary tree problem walkthrough today, and then we're going to go dive into breakout sessions. So today we're going to do max sum BST and binary tree. So this is a little bit more involved, but I don't think it's too hard to grasp. So we're going to talk about this today. We're going to solve this using umpire. So given a binary tree root, the task is to return the maximum sum of all keys of any subtree, which is also a BST. So let's make sure we read this problem carefully, because remember, you want to make sure you're solving the right problem when you're given a question. So assume a BST is defined as follows. Whenever you see a question that has an explicit definition of a data structure, make sure you read through that carefully, because some questions might have a slightly different definition of a BST. So in this case, a BST is the left subtree of a node contains only nodes with keys less than the node's key. And the right subtree of a node contains only nodes with keys greater than the node's key, all right? And the last one is both left and right subtrees must also be BSTs. So let's make sure we take these three rules into account, because whenever they explicitly define these rules, you want to make sure you pay attention. So they give us an example over here. So you have this tree over here, and the maximum BST subtree is one's right subtree over here. All right. So let's first talk about why the left is not a BST. Well, let's see. Let's look at the definition that they gave us. Both left and right subtrees must also be BSTs. So if the root is at 1, its left subtree must also be a BST. Well, let's look at this left subtree. This left subtree has a root of 4, has a right node of 4, has a left node of 2. Now, if we look at our definition over here, the right subtree has keys that are equal to the root. So this is not actually a BST, okay? So in this case, we can't include this to be in the maximum sum because this is not a BST. Hence, this root is not a BST as well. This right subtree is a BST, and let's talk about why. Because the root 3, all the keys to the left of 3 are less than 3. It's only 2. And all the keys to the right of 3, 5, 4, and 6, are all greater than 3. And also, 3's left subtree is a BST. A single node is a BST. And 3's right subtree is also a BST. The root with 5 is also a BST because all the keys to the left of 5, which is 4, is less than 5. And all the keys to the right of 5, which is just 6, is also greater than 5. So this subtree over here is a BST. If you add all of this up together, you get 2 plus 3, which is 5, plus 5 is 10, plus 4 is 14, plus 6 is 20. So your output is 20. Okay, so let's go through a few more problems together to make sure we understand what is happening. Now let's look at this example over here. Now, the maximum subtree of this for this example is just 2. And why is that? Okay, so let's look at 4 again. For 4, in order for this to be classified as BST, its left and right subtrees must be a BST. That means the root starting at 3 must also be a BST. Well, in this case, it's not a BST because the keys to the right of 3, which has 2, is less than 3. So this is not a BST. So this root cannot be a BST. This one can be a BST because it's a leaf. It's just 1. But this one has a larger value. This is also a BST. It's a leaf. So the maximum value, maximum BST sum for this tree is just 2. Okay. Now, whenever we are testing trees, it's always important to account for negative values and also duplicate values. Those are usually the cases that you need to watch out for. Those are nice edge cases to test when you're developing tree test cases. In this case, if we have a tree that is all negative values, you would just output 0. So some people might think, oh, you just output the highest or the highest value, which would be -2. But in this case, we would just output 0. Let's see. This example over here. Let's see. Let me just start drawing this out. 213, which looks like this. This is a BST. All the values to the left of 2 are less than 2. All the values to the right of 2 are greater than 2. And they are both left and right subtrees are also BSTs. They're both leaves. So the maximum value here would be 1 plus 2 plus 3, which is 6. Okay. So I think we've gone through a good amount of examples. Now that we kind of understand the problem, let's go through the match step, which is identifying what kind of problem this is. Again, for a lot of tree problems, it's very easy to know when you're doing a tree problem or a binary search tree problem. It's because you're already given a tree or a binary search tree, and it's clear in the problem that you are given a binary tree. So that's very easy. The next one is the plan step. And in the plan step is when we determine what kind of traversal we are going to do. Now, in order for us to know what the maximum sum is in a BST, then we would need to go through every single single node, because a leaf is also considered a binary search tree in this definition. So, in order to figure out, if we start from this node and we want to figure out what the maximum sum BST is in this tree, then we first need to look at our children, right? And for this node's children, we need to look at this node's children as well. Well, guess what? What kind of traversal does that remind you of? If you first need to look at your children, exactly, post-order traversal. That is the traversal that we need to do. We probably can't do pre-order traversal here because in order for us to figure out the maximum sum, we first need to look at our children. And then process the current node that we're at. So post-order traversal here would be a very good candidate. All right, so sounds reasonable. Let's keep going down this hole with using post-order traversal. So let's go through this example over here. So first, we're going to start at this root over here. What is the maximum sum BST of this node? Well, I don't know. I first need to go look at my children. I'm going to first look at my left child. Okay, and I ask myself, what is the maximum sum BST starting at this root? Well, I don't know. What is the maximum sum BST of my left child? So I'm here at 2 now. Well, starting from this root, it's a leaf. So the maximum sum BST for this node is just 2. So we're going to tell we're going to tell the parent, like, okay, the maximum sum BST of your left subtree is 2. Right? That's the sum. 2. Also, remember the definition here. Assume a BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key, right? So we should probably also keep track of the minimum value and the maximum value of the left subtree. And we're going to pass that back up to the parent, because in order for this definition to be valid, we need to know what the minimum and maximum values are of my left and right subtrees. So we know whether or not that root is a BST. So the minimum value in this case is 2. And the maximum value for this case is also 2. And also, we should probably tell the parent whether or not its subtree is also a BST. So in that case, I'm also going to pass in a Boolean, true or false, signifying whether or not that subtree is also a BST. So we have a few things we need to pass back up to the parent. We need to pass back up the sum. We need to pass back the minimum value in that subtree, and we need to pass back up the maximum value of that right subtree, and we need to signify whether or not that subtree is a BST. Okay, and we're going to do that for the right child as well. We're going to pass in 4 as the sum. The minimum value is 4. The maximum value is 4, and the it's also a BST because it's a leaf. Now, once we're doing that, we also want to keep track of the maximum sum BST that we found. So in this case, we need to somehow keep track of the maximum sum that we found so far. In our case, we can probably just update a variable and update it with the maximum we've found so far. In this case, since we traverse a leaf and we know that a leaf is a BST by default, we can just update and see whether the maximum sum we found is higher and update it if necessary. Now we're back up to this parent. Now this parent is basically going to say, okay, now that I've traversed my children, is this root a BST? Okay, so what we're basically going to do here is, okay, my left subtree is a BST because it passed back true. My right subtree is also a BST, and that's true. And the maximum value of my left subtree is less than my current value, and the minimum value of my right subtree is greater than my current value. Those need to hold true because of these definitions. The left subtree of a node contains only nodes with keys less than the node's key, and the right subtree of a node contains only nodes with keys greater than the node's key. So these 3 things need to hold true. And if those 3 things hold true, then I can update whether or not this new sum is higher than the maximum sum I've found so far. And then after that, I'm going to pass back those values back up to the parent, and we're going to do basically the exact same thing. All right, so let's put this into a concrete plan. So first of all, if node is a leaf, then pass back its value. Min val, max val is BST. All right. If not, then traverse left subtree, then right subtree to figure out whether or not they are BSTs. Okay. Once you have those values, figure out whether the current node is also a BST by checking if BST is true for both children and all keys of left subtree are less than the current node and all keys of right subtree are greater than the current node. Right? And then also we want to, let's see, let me just organize this a little bit. Update max sum BST if needed whenever you find a BST node. All right, so this is basically what we're going to do. In order to keep track of the maximum sum BST we found so far, I'm just going to initialize an instance property. In this case, if you don't want to initialize an instance property, then you can just pass in an array with one element. So that will be passed by reference in Python, and you can just update that array. In this case, I'm just going to use an instance property. So I'm going to initialize my max sum to be 0, because that is the minimum value we should return. And then what I'm going to do is I'm going to create a helper method, self.maxSum BST helper, which will recurse for me, which will do the recursing for me in the tree, right? And this will just pass in the node. And what this will return is it will return multiple values, right? It needs to return a Boolean whether or not that subtree is a BST, or that node is a BST, and it needs to return 3 int values. And what those int values are is, well, the Boolean is going to be is valid BST, right? The is valid BST is going to be this Boolean over here. The next one is going to be the sum of that BST. And the next one's going to be the minimum value of that node, rooted at that node. And the next one's going to be the maximum value rooted at that node. Okay, so this is what our helper method is going to do. Why is what's happening with LeetCode? Come on. Okay, so what we're going to do is we're going to call this helper method over here. We're going to pass in the root. We're going to start there. And all we need to do in the end is we're going to return what self.maxSum is. And we're going to update self.maxSum whenever we find a BST node. So whenever we are coding up a recursive method, what we're going to do is we first need to figure out what our base case is going to be. And in this case, in a lot of patterns you guys will see in recursion is if the current node is none, then I'm just going to return these default values. I'm going to assume that it is a valid BST. I'm going to pass in a sum of 0. My minimum value is, I'm just going to initialize this to some large placeholder number, and my maximum value is going to be some very small number, right? This is going to be my base case. And you guys will see why I do float ints and float negative ints in a bit. But that's our base case. Okay, so once we know that we have a current node, then we should traverse our left subtree and our right subtree first. And thank you for reminding me. I always forget this in Python. Is this in this self over here? Thank you for reminding me. So we're gonna traverse our left subtree first. So we're gonna do self.maxSum BST helper. We're gonna pass in node.left. Okay. So now this will return a tuple or a tuple, whatever you want to call it. I'm in team tuple, so I'll say a tuple. So this will return a tuple with 4 values: is valid BST, sum, min val, and max val. So what I'm going to do is I'm just going to destructure this, aka I'm going to put these into different variables so that it's just much more readable. So what I'm going to do is the first element of that tuple is is left valid BST. The second variable or the second value in that tuple is, I'll call that left sum. The third value in that tuple will be the minimum value of that left subtree. So I'll call that left min val. And the last one will be left max val. And I'm just gonna do equals to the result of this, which is going to be a tuple. And what Python will do for me is it will assign each value in that tuple to the correct variable. So it will assign is left valid BST to the first element in that tuple, left sum will be to the second value in that tuple, and so on and so forth. Okay. I'm going to do that for my right subtree as well. So I'm just going to copy pasta this, and I am going to change this to is right valid BST. Okay, do this as well. Okay, so now I have traversed my left and right subtree. The next thing to figure out is whether or not the node that I'm currently at is a BST. All right, so let's do some checks. If the following things are true, then I know I am not a BST. If my left maximum value, if the maximum value of my left subtree is greater than or equals to my current value, then I am not a BST based on these definitions over here, right? Or if my right minimum value is less than or equals to my current value, then I am not a BST. Or if it's not a valid BST over here, or not is left valid BST, or not is right valid BST, then I am not a BST. So I'm just going to return false because I'm not a BST. I'm going to return 0, and I'm just going to return some placeholder values. Okay. Cool. So these checks over here are just basically corresponding to these definitions over here. So now after we get past that, we know that this node is a BST. So we want to check whether or not the current sum at this node is a new max sum. So we're first going to assign cursum to be node.val plus left sum, right? Plus right sum. These are the BST sums of the left and right subtrees, and we're going to add that to the current node's value. And after we do that, we update max sum if we need to. So self.maxsum is equal to max, self.maxsum, cursum. All right, we just update the max sum if we found a new max sum. And then after that, we return another tuple, true, because this node is a valid BST now. The sum will be cursum, the BST sum rooted at that node. And the minimum value will just be the minimum of node.val or left min val. And the maximum value for this subtree will be the max of node.val or right max val. Okay. So let's just review our code real quick. What I like to do is after I code up something, I like to do a quick glance to see if there's any egregious syntax errors. So let's first start from the top. This seems right. This seems right. We return self.maxsum. That is correct. This will take in a node and return a tuple. If node is none, we return true with a bunch of placeholder values. That is correct. We basically destructure this and put this into different variables for readability. That seems correct. We do this for the right subtree as well. And then after that, we check that the maximum value is, if it's greater than or equals to the node value, that's not a valid BST. So we early terminate over here. If the minimum value is less than or equals to the node value, that's also not a BST. And we also check is left valid BST or is right valid BST. Cursum, node.val plus left sum plus right sum. Yep. And then we update maximum value, and then we return true cursum min node.val left min val max node.val. Okay. So this seems, I think this seems correct to me. So we got 4 minutes, and I want to make sure I explain to you guys the breakout sessions. So I'm going to go ahead and skip the review portion. I know I keep skipping the review portion. That's bad, but I'll make sure I plan properly next time. But in terms of evaluate, we have to walk through every single node. So the runtime is O of n, where n is the number of nodes. Since we are using recursion and since we might get a degenerate tree, I believe the space complexity for this one will be also O of n, where n is equal to the height of the tree. So if I run this, seems fine. Okay, seems fine. Okay, good. So it looks like there are some questions over here. I will answer them during breakout sessions. It's really hard for me to answer questions and do a lead code problem at the same time. But I'll go ahead and I'll comment on them during breakout sessions, but I want us to go ahead and talk about the breakout sessions because the mentors are here. And also I want to do a different exercise with you guys today. So, all right, breakout session today. I want us to try something new. If you guys are up for it, I want you guys to do a mock interview with each other or with your pod. So how is that going to work? I know there's some questions here right now. So for breakout sessions today, we have 60 minutes. If you feel comfortable with your pod, mentors, I will let you, also I will give you guys, mentors, I will give you freedom on whether or not you want to do this exercise. If you want to keep doing problems individually, if you want to keep doing it as a group, feel free to. What we found in the last cohort is that people actually found it useful to see how an actual interview is. So I want you guys to do this exercise if you want. So it'll be 45 minutes of interview and 15 minutes of discussion and feedback. So what does that mean for each one of you in the pod? One of you will be the interviewee. That will be the person answering the questions. So, if you're the interviewee, just relax. This is just a learning exercise. Also, trees might be annoying to draw in REPL or Google Docs or whatever you guys are using to collaborate with each other. So have a piece of paper handy. Interviewer. So there will be one interviewee. There will be obviously one interviewer. For your interviewer, just send whatever collaboration doc that you guys are using so that you guys, everyone can see. And the rest of the people in the pod will be observers. So that means if you are not the interviewee or the interviewer, mute and turn off your video. Also take notes. Be constructive in your feedback. Also, if your mentor couldn't make it, please message me on Slack and I will send you the mentor guide. But take notes, observe what is going well, what is not going well. And in the end, just give feedback to both the interviewee and the interviewer. Now, I want to stress how, your feedback should be respectful. It's obviously, it's very nerve-wracking to be interviewing, especially if there's multiple people observing you. So please be very respectful of your pod members, be cognizant of how they could be feeling. And, you guys are a pod, you guys are a team. You guys should be helping each other instead of putting each other down. So please, just relax. This is just a very casual exercise. If you guys don't want to do it, then, yeah, feel free to do it individually or as a group, just like what you guys have done in the previous breakout sessions. So let's see. Any questions about the exercise today? Let me see. Okay, for you guys who have your video on, does this exercise seem clear to you? Can you give me a shake, a nod if it's clear? Good, I see some nods. Okay, good. If your mentor's not here, please message me. I'll send you the mentor guide. Okay, sounds like there are no more questions. So Daphne, let's go ahead and go into breakout sessions. From breakout sessions. Welcome back to the main room. Mentors, thank you so much for coming. I'm sure your students really appreciate it. We're just gonna recap the breakout session, but feel free to go. We will see you next week. Again, thank you so much for all your help. And students, please never forget to thank your mentor. They are literally here out of the goodness of their hearts. So please make sure they feel appreciated. So thank you again, mentors. Feel free to go. Okay, so if you did the mock interview exercise that I told you guys, then expect these types of questions with a similar format. Usually in a typical interview, you would have 45 minutes to an hour to solve one or two questions. Depending on the difficulty, you might get 1 to 2 questions. Also, for some people out there that was like, no way, I got 3 questions in an interview one time. That's totally possible. The point of one of the things that a good interviewer does is they don't really waste time in terms of what you want, but basically as a good interviewer, you want to maximize the amount of signal that you get in an interview. So if you finish early and we're able to do 2 questions, it's totally possible that an interviewer might give you another question just so that they can get more signal on how good of a coder you are. It's obviously a good sign if you already gone through 2 questions, but don't expect that there will only be at most 2 questions, because a good interviewer will always fill out the entire time for the interview to get as many signal as they can. Let's see. So usually, if there's 2 questions, expect it to be like one on the easier side, one on the medium side, or you can get 2 mediums as well. If it's on the harder side, you might just get one of those questions for the entire session. So just keep that in mind when you're practicing. Also, use this as motivation to keep practicing. If you found it really nerve-wracking to code with some people observing you, that is how you're going to feel in an interview. So make sure to acknowledge that, and also to practice with that kind of environment, because what you don't want is, you don't want to just be feeling comfortable coding in your couch doing leak code, but when it comes to the interview, you kind of start sweating bullets and you forget all the things that you've learned because you're so anxious. So part of it, a lot of this is mental training as well. So make sure you expose yourself to these types of situations, because when it comes to interview, that's it. You might as well, if you wanna fail, you wanna fail before the interview as much as you can, because when it comes to the real thing, that's it. Okay, this is our first round of mock interviews. So please, in the feedback form that I will ask again at the end of the lecture, please tell me how it went. If you didn't end up doing the mock interview and just ended up doing individually, please let me know why you decided to do that, just so that we can adjust throughout the course. Because this is the first time we're trying it out with you guys, and we want to see how it went. Okay. Before I talk about other types of interviews, I just want to go through a few of the problems that you guys should have gone through in your breakout session. So one of them should have been converting a sorted array to a BST. The main thing here to realize is that if you take the middle element of this sorted array, the left subtree is all the elements to the left of that middle element, and the right subtree is all the elements to the right of that middle element. So in my case, what I did to solve this was I just did this recursively, where I would get the middle element on each iteration of the recursive function, and I would build my left subtree by doing another recursive call and just adjusting the index and getting the middle element of that subarray. So that's one way to go about it. Again, I like to use recursion for a lot of these because it's a very elegant way to solve these binary tree problems. Let's see. Next one, print a binary tree in vertical order. I love this question. Anyone else found this question really fun? I found this question really fun. I see some smiles and they're like, what do you mean fun? But this is a really interesting problem, because you don't, I think one of these really cool ways to traverse a binary tree. But basically what you could have done here is you could have realized that you could have traversed this in such a way to get the vertical or the horizontal distance of each node. You could have gotten the minimum horizontal distance and the maximum horizontal distance. So in this case, for this tree over here, the minimum horizontal distance is this one over here, which is -2. The maximum horizontal distance is this node over here, which is 1, 2, 3. So once you have those two values, what you can do is you can iterate the tree again and print it in vertical order once you know the horizontal distance. So you would print from the minimum horizontal distance all the way up to the maximum horizontal distance, and you would traverse the tree for each horizontal distance, and you would print the values as you find those nodes. I believe you can also do this with a dictionary. What I also thought you could do here is you could have an auxiliary data structure dictionary where the key would be the horizontal distance and the value would be an array of values at that horizontal distance. Okay, very cool way. You don't really. This is a very interesting problem, and this will probably be on the harder side. Leak code also has this a variant of this problem, but I found that that one's a little bit harder to solve because of how they break ties between horizontal distances. So I think this one is an easier variant of that. But yeah, there's one on leak code as well, but slightly different way of breaking ties. Cool. The last one, this is optional, is finding the largest value in each tree row. Guess what? Remember those keywords we talked about in the last lecture? Row. What is that? What traversal does that remind you of? Level order traversal, right? And this is just a simple level order traversal. Cool. So that's that. If you guys found that hard, again, spaced repetition is key. Repeat these problems, learn from it, and be able to apply it for other problems you might see in the future. Okay. So now we're going to switch gears. I'm done talking about binary trees. We're going to talk about something that I think is also very important and that you guys should be aware of, and that's other types of interviews. Surprise, surprise, there's more to acing interviews other than getting good at whiteboarding problems. And we're going to talk about what those are because you should also be practicing for them. Practice never stops. So there are other types of interviews. The other common types of interviews are screening interviews. These are the first interviews you usually have with the recruiter. Next one is behavioral interviews. Interviews that you would usually have with a manager that talks about your non-technical skills. Also, we have role-specific interviews, which is basically this is the type of interview that stresses your skills that will be needed in your day-to-day job. So usually in your day-to-day job, you'll never need to reverse a linked list or traverse a graph or anything like that, especially if you're a front-end web developer. So this type of interview stresses like your front-end web dev React skills, your iOS, Android skills, whatever role you're specifically applying for, if it is a specialized role. Lastly, system design. For the vast majority of you guys, this is kind of like on the horizon. As you get more senior, as you apply for higher level positions, these types of interviews become more important because they stress you and try to get a gauge of how good your architectural skills are. So we're going to talk about that as well. And the key point here is that you want to allocate your practice accordingly, depending on the companies that you're applying for. So for example, I would practice very differently if I wanted to get a job at Google, Facebook, Amazon, than if I were to apply for a startup that cares a lot about my role specific skills. So it's very common for big companies to give you the generalist type of interview where they ask you purely algorithmic and data structure skills. But some other companies have switched to doing role-specific interviews that ask more iOS-specific questions, Android, front-end web dev, React. So the point here is, depending on what your goals are, you want to tailor your practice to those goals. So if your goal is to get a job at Google, man, you better go ham on leak code. But if your job is to get at this company, at this smaller company, at this startup that asks mainly role-specific questions, then you probably want to practice more on that, right? So let's talk about screening interviews. This is usually the first interview when you're applying. This is when you hop on the call with a recruiter. It's kind of an exploratory call. They try to evaluate your qualifications to see if you would be a potential fit for the role, okay? Just to see if things are kind of, the skills that you have is roughly what they are looking for. They also ask any clarifying questions about your resume. They might ask you to dive in a little bit more specifically about your contributions to this project, what skills you know, and what skills you've used in certain projects. They might also ask about your motivations and why you're applying in the first place to see if they're the type of employee that they're looking for, that shares their values. This is mostly non-technical because they're conducted by recruiters. There's only so much technical questions, not a lot of technical questions that a recruiter can ask you. They might ask some technical questions that is scripted, that is written by engineers just to filter out and see if there's any red flags in the beginning. So for example, if you're an iOS developer and you can't explain to me how to build or like how to create a certain, a very basic UI component, and you give me the wrong answer, you probably shouldn't be applying in the first place. So, recruiters can filter out really, really big red flags like that in the beginning to avoid wasting time for the others in interviewing. Does anyone have any questions about screening interviews? This is usually the first interview that you will encounter. A lot of companies do this type of screening interview. This is separate from a technical phone screen, okay? Just to be absolutely clear, that is separate from this. This is the call with the recruiter. And I'm sure for you guys who have interviewed, you guys have probably encountered this call. All right. Next one, behavioral interviews. The point of this is to understand how you work and what your behavior is in a working environment. So usually these interviews consist of asking about your soft skills, asking about your past experience working in a team or in a company. And there's usually at least one round of this during full-time and intern interviews. And it's usually conducted by managers because managers are the people in the company that are more attuned to these types of skills because they deal with people all the time. Sometimes a senior engineer might also do this, but for the most part, in my experience, managers like to do this. So they might ask you about like common questions are like, tell me one time where you had a disagreement with someone, or tell me what you're most proud of, just to get a sense of what kind of person you are and how you work with others. And, you guys, there's a lot of popular behavioral questions out there. If you just Google it, you guys can get a sense of what they are. But you might be asking, well, Mari, how do I answer these types of behavioral questions? Kind of like umpire, is there a framework that I can use to answer most behavioral questions? And yes, there is actually. There is one method that people like to use. It's called the STAR method. Has anyone actually heard of the STAR method? I see some nods. Good. I see some thumbs up. Awesome. Yeah, so STAR method is just a popular framework that you can use to answer behavioral questions. So for example, if I get asked, tell me about a challenging situation you had at work, one of the very common behavioral questions. S stands for situation. That is basically just setting up and describing the situation. So for example, in my case, I would say, I was on call and I got an alert that errors for our main backend service were spiking in the middle of the night. Okay, just set up the scene. What happened? The next step is task. What is your responsibility in the situation? Okay, what is your job? So as on call, my role is to make sure our services are stable and to triage and mitigate escalations when they happen. Right? That's my task. That's my job. The next thing is action. So what did you do to accomplish that task? Well, I looked at the timeline for when the error started, along with the changes that were made at that time. I found the offending change and I reverted it. And it was from an intern. Just kidding. But you guys get the point of this step is just describe the action that you took to accomplish the task. The next step is results. So this is kind of the icing on the cake. What is the outcome of those actions? The errors, which affected X users, was mitigated in Y minutes. You can also, if you really want to get fancy, you could kind of tie that to like the revenue of the company, like which saved the company $Y million, whatever. In Facebook, that's very common. So I also led a postmortem afterwards, which led to creating more automated tests to prevent it from happening again. So that is the results. What is the outcome of your actions? I like to use this framework because it kind of it walks the interviewer through all the context and the things that you've done and the results of your actions. And I really like using this for behavioral questions. So what I would do to prepare for these types of interviews is I like to look at the most popular behavioral questions out there, just Google them and practice them using the STAR method. And just to get very comfortable with using this method to answer behavioral questions. I find that this helps me keep calm, kind of like umpire. Why I love it is because whatever question I get thrown in, I know for a fact that I can use this framework to answer it. So that helps me keep calm in an interview. How long should an answer for a behavioral question be? Roughly 3 to 5 minutes. Yeah, that's a good question. So it really depends. You also want to get some signal for your interviewer because they like to indicate how deep they want to go in a question. So what you don't want to do is you don't want to talk for 10 straight minutes without giving your interviewer time to ask, to go in a direction that they want to go in. I hate those types of interviews where they just keep talking and they don't give me or give the interviewer time to kind of like go the way that they want to go, because that's kind of where this that's a signal that we want to get. But if an interviewee doesn't give us the time to interject, then we're not really getting valuable signal anymore. So make sure that when you are explaining things to your interviewer, give them time to ask follow-up questions. Okay, don't just hog the mic and just keep talking. Okay, because what an interviewer will do is they want to prod you to the right direction, and if you keep talking and don't give them the chance, they won't be able to get the signal that they want. So in terms of how long you should have an answer for, just answer it. Give like a base description of your answer. Give it like 3 minutes. If the interviewer wants to dive deeper into that, they'll tell you to. All right, just don't hog the mic for like 10 minutes. Okay, any more questions about this? I see someone typing, so I'm going to wait. Speaking too much versus speaking too little. Yeah, so that's definitely an art. You obviously just don't want to give like a one-sentence answer to the question, but you also don't want to give a whole eulogy for your answer. So this is going to have to be a thing that you kind of get a gauge of. For me, when I answer a behavioral question, I usually give like about a 3-minute answer. Then I let the interviewer drive it from there to see what direction they want to go in. How do you convey the story in 2 to 3 minutes? So for some stories, it might take a little bit longer, maybe 4 or 5 minutes, but I wouldn't really go more than that. Also, what you'll find is as you get more of these behavioral questions, you will find yourself getting used to them and be able to explain them in a more concise manner. Can we use the same story again and again? Obviously, if you're applying for different companies, you get to ask the same question. Yes, you can do that. If it's in the same loop, it's a good question. Usually, if it's in the same loop, the interviewers like to collaborate and make sure that they don't ask the same type of questions. So if you keep getting asked the same type of questions, I think the problem is on their side, that the interviewers just aren't collaborating with each other and they just keep asking you the same questions. I wouldn't worry about that too much unless the company you're applying for is very unorganized. Usually in a loop, interviewers should talk about what kind of questions they want to ask so that they don't kind of ask the same thing or ask the same domain, because that's just wasting time. It's a red flag for a company, correct? Should we tailor our answer to show our technical skills, or are behavioral interviews solely for soft skills? It's both. I wouldn't really, I would say behavioral interviews are more to get a sense of your soft skills. However, when you're explaining your soft skills and your accomplishments, sometimes it's inevitable that technical things will come up, and that's fine. You can kind of talk a little bit about that, but just remember that the point of a behavioral interview is to get a sense of your soft skills, and the point of the technical interviews is to get a sense of your technical skills, right? So the whole goal of the interviews are different. Any more questions? Cool. All right, role-specific interviews. So the point of this interview is to deep dive into your domain-specific knowledge. For example, if you're interviewing for iOS, Android, front-end web dev roles, AI, ML, data science roles, you might get some interviews that are purely stressing and asking for these skills. So this could be mixed with algorithmic and data structure interviews as well. So this could be a hybrid, right? You might get asked an algorithmic data structure question followed by a role-specific question about some framework that you should know about, and vice versa. So there's these types of interviews as well. Make sure you prepare for them. Don't just be practicing purely LeetCode. You should also be practicing the platform that you should also be practicing skills for your platform. Some companies have fully switched to doing these types of interviews. For example, a lot of startups find that role-specific interviews are much more useful for for their case, instead of just asking you purely about data structures, they might ask you more about what your skills that you would need for your day-to-day job. So the point here is your technical interviews can be, you can think of it like a spectrum. You can see technical interviews that are purely role specific, and you can think of technical interviews that are purely generalist / algorithmic and data structures, right? And your technical interviews can be anywhere in between, depending on the company, right? So for example, Google, Facebook, and Amazon are probably going to be more in this side where they care more about your generalist skills. Startups might be more on this side where they care more about your role specific skills, and anywhere in between. So now you're wondering, well, Mari, how do I know what to prepare for? It's a great question. What I like to do when I was interviewing is I would go on Glassdoor and I would look at what type of questions they like to ask my role for. And so, for example, I would go to this for some company, and I found that, oh, this company loves to ask role-specific questions, and they don't really ask a lot of data structure questions. So if my goal was to get a job at that company, I would probably practice more of my role-specific skills rather than software generalist skills. But if my goal was to get a job at Google or Facebook, then I should probably be practicing more software generalist, algorithmic, and data structure skills. If you are interviewing for a specialized pipeline, for example, iOS, some big companies have specialized pipelines for that. So make sure to ask your recruiter what pipeline you're in. If you are in that special pipeline, they will also ask for some role-specific questions as well. Any questions about role-specific interviews? Also, what I like to do when I was practicing my role-specific skills, I also made Anki flashcards for them. So if you guys want to do that as well, I Ankify a lot of things, especially when it comes to interviews. Cool. All right, system design questions. This is kind of in the horizon for you guys. This is usually for experienced hires, and it's not really common for interns and new grads. And the point of this is to understand how well you're able to design an end-to-end system that is either in or slightly outside of your normal domain of expertise. And now I know some of you guys are like, wait a minute, Mari, I got asked a system design question. That's not true. Okay, yeah, you might get asked a system design question. Like, in my personal opinion, I don't know why you would ask a new grad or an intern how they would design Google backend or Facebook app. But when I mean system design questions, I mean those types of system design questions. I don't mean like, oh, design a parking lot or design Sudoku or tic-tac-toe. That's not really system design. That's more object-oriented programming questions. And that's totally fair game for you guys to get asked that, because that's much smaller in scale. But in my opinion, asking an intern or a new grad how they would design Google backend or Google search, I think is a ridiculous question. Like, yeah, you could say, oh yeah, well, maybe they just have a lower bar. Well, if your bar is so low, why are you even asking that question? So that's just my personal opinion. I don't really see companies asking those types of questions a lot for junior roles. However, once you're in the industry and once you're looking for more mid-level, senior level roles, expect these types of interviews to come up. Okay. And this is because companies use this type of interview to determine your level, right? Because the point of this interview is to get a gauge of your architectural skills. Companies like to use your performance in this interview to determine how senior you are of an engineer. So if you're interviewing for a senior level position in the future, you should be practicing your system design skills. And that's a whole separate topic that we're not going to get into. That's its whole own world that I fully don't have a good grasp in. So that's a totally separate topic. Let's talk 5-10 years later on this. How do you prepare for OOP questions? Yeah, that's a good question. You can look at the most popular OOP questions out there. Also, I find that a lot of OOP skills come with just doing projects on your own, and also looking at other people's projects. So that's how I would go about it, is just get popular with the popular OOP design patterns for your platform. So for example, if it's totally possible that I could get asked an OOP iOS question, Discussion. And a lot of my knowledge for that would probably come from my past experience in building apps, right? So that's how I would prepare for OOP questions. Okay, cool. So before you leave, I am once again asking you guys to do this feedback survey. I know it's very repetitive, but please, please, please do it. After you've done this and you have no more questions, feel free to go. I will see you guys, not next week. Iris will be teaching next week, but I will teach after Iris again for the second part of graphs. So please do the survey and feel free to leave once you've done it. And if you don't have any more questions, I am going to open this up. I'm going to stick around for about 10 minutes to answer any lingering questions you guys might have in today's lecture. Let's see. All right. I'm going to stop sharing my screen now. So is it reasonable / expected to negotiate salary as a new grad / intern? Yeah, it's totally reasonable. And honestly, I would go even so far as it's expected. I would expect any person who has an offer to negotiate that offer. Now, I'm not saying to, here's the thing, people, when it comes to negotiating, it's all about how you negotiate, right? So here's the thing. I feel like, in my opinion, I think it's still fair game for you to negotiate with an offer, even if you don't have any competing offers. Even if it's your only sole offer, you should still try and negotiate respectfully and also reasonably, okay? As long as you do it respectfully and reasonably, negotiating your only offer is totally reasonable, and recruiters expect it, right? So I think you should still be negotiating your offers, even if it's the only offer that you have. And if you have multiple offers, heck yeah, you should be negotiating. The thing to note is, for most companies, most recruiters, actually, if not all recruiters, they don't give you the best offer as their initial offer. Who in the right mind would do that? Like who, like, okay, yeah, this person got it, I'm just gonna give them the best offer as my initial offer. No person, no rational person would do that. So please negotiate your offer, do it respectfully, and also, come up with good reasons why they think you should increase, they should increase your offer, right? If you have competing offers, that's a great reason.